Hello everyone, my name is Prajakta Kulkarni and I was doing this course on Coursera for AI product management wherein there is this project where we have to predict the electrical energy output based on the data set collected, including the features such as temperature, pressure, humidity, and exhaust vacuum. So, looking at the data set in the first place, we have around 9,500 data points. And to understand the features closely, I have created the scatter plots in the first place for all of them. And looking at all these scatter plots, I have understood that there are not many outliers in the data. They look evenly distributed. Uh, that is why we can use the mean absolute error or mean absolute percentage error for the model. Now, the values of the features are continuous and the predictions are also um, in a similar way, which is why we would go ahead with linear regression problem. So to implement that, I have chosen sklearn library from which I have used the linear models, and I have written these codes. So, firstly, for a plain linear regression, I have just read the CSV, decided on what input features I would select, and the output feature that I want. Then I have split the data set into train and test sets with a split of 80% and 20%. Then I have used the linear regression model. I have fit it to the train set likewise, and then I've predicted the energy output values on the test set. So I have printed these values also, and I found out that they are pretty close to the actual test values. Then I have printed all the errors. So as I mentioned earlier, I would be looking at mean absolute percentage error mainly, but I have documented all the other errors also to understand the trends. Then I also tried using rich regression and lasso regression for the same to see if there are any improvements on top of this model. So similar to the linear regression case, I have imported it from the sklearn's linear model library, and I have um, trained it like this. Um, and I have printed the similar results here also. And same thing for lasso regression. Now, for lasso regression, I found out that the results have been a little better. So I took the liberty to experiment a little bit with the regularization parameter alpha here. So I've tried different values like zero point 0.4, zero point 0.6, zero point 0.7 rather than zero point 0.5. And I found out that with zero point 0.6, the values uh, have been at the best of all cases. So let's look at the results quickly. So for mean absolute percentage error, I have run all these four models. I have not documented results for alpha zero point 0.4, zero point 0.7, and other cases as those were not very significant. Um, now, the input features that I've selected were these three combinations: temperature and exhaust vacuum, temperature, vacuum, and the pressure, and all features at a time. So I have documented the error for all these cases in this table, and as you can see, this is the minimum error that I got for all features and for lasso regression at alpha zero point 0.6. So I have also looked at the other errors at the same time, and you can see there have been similar trends for them also. So, yes, I would use all features to solve this problem, and I would use lasso regression model with alpha at zero point 0.6. Thank you.